Hey guys, I am Sachira Amarasinghe. Today I'll be doing the 2017 14th question. So the question A, part 1, show that 2 cos 60 minus theta minus cos theta over sin theta equal root 3 for theta is greater than 0 and less than 90 degrees. Second part, in the quadrilateral ABCD shown in the figure, AB equal AD. ABC equals 80 degrees, CAD equals 20 degrees, BAC equals 60 degrees. Let AC equals alpha. Using the sine rule for the triangle ABC, show that AC over AB is equal to 2 cos 40 degrees. Next, using the sine rule for triangle ADC, show that AC over AD equals sine 20 degrees plus alpha over sine alpha. Deduce that sine 20 plus alpha equals 2 cos 40 degrees sine alpha. Hence, show that cot alpha is equal to 2 cos 40 degrees minus cos 20 over sine 20. Now, using the result in part 1 above, show that alpha is equal to 30 degrees. B part, solve the equation cos 4x plus sin 4x equals cos 2x plus sin 2x. Okay, now we'll get on with the question. Okay, let's start the first part. It says that show that 2 cos 60 minus theta minus cos theta over sin theta is equal to root 3. They are saying us to prove this equation is correct. So what I'm going to do is that I'm going to take the left hand side of this equation and I'm going to equal it to the right hand side. So I'll take the left hand side, LHS 2 cos 60 minus t, 2 cos 60 minus theta minus cos theta over sin theta. That's the left hand side. So I should equal this part to root 3. So first what I'm going to do is I'm going to expand this cos 60 minus theta. So first I'll take the 2 here. I took the 2 and when we expand cos 60 minus theta, it will be cos 60 into cos theta plus sin 60 into sin theta. So this is what we get when we expand cos 60 minus theta, and then I write the remaining parts of the equation minus cos theta and sin theta. Okay. And we know that I write the 2 here, and we know that cos 60 is half. And when we multiply half, which is cos 60, by cos theta, it's going to be cos theta over 2. So I'll write cos theta over 2 plus, and we know that sin 60 is root 3 over 2. So when we multiply root 3 over 2 by sin theta, it will be root 3 sin theta over 2. So I'll write root 3 sin theta over 2. And I'll write the remaining parts of the equation minus cos theta over sin theta over sin theta. And so what I'm going to do next is I'm going to remove these brackets, so then both these terms will be multiplied by 2. So when you multiply cos theta over 2 by 2, it will be cos theta. The 2 will be cancelled and the same will happen to the root 3 or root 3 sin theta. So I'll write it here. Cos theta plus root 3 sin theta minus cos theta over sin theta. I'll write it over here, it's very easier for me then. Cos theta plus root 3 sin theta minus cos theta over sin theta. So these two are the terms that I multiplied by 2 and these two are the remaining. And we can see that we have minus cos theta and plus cos theta here. So we can count those two terms. And then we are having root 3 sin theta over sin theta. You don't have to write this step, but I am writing it because it's clear. Then we can cut this sin theta and sin theta, then you will have root 3. Then we have proved that this equation is correct by proving that right hand side and the left hand side are equal. So that's it for the first part. Thank you. Okay, let's start the second part. It says that in the quadrilateral ABCD shown in the figure, AB is equal to AD and ABC is equal to 80 degrees, CAD is 20 degrees and BAC is 60 degrees and ACD is alpha. And in here you can see that I have marked the angles ACB and ADC. So they are the two remaining angles that we don't know. I got it by the like we know that the sum of angles in triangle are 180 degrees, so I got it by that. And in here it's 180 minus 20 plus alpha, because we don't know alpha, I just kept it like that. So we'll get on with the question then. It says using the sine rule for the triangle ABC, show that AC over AB is equal to 2 cos 40. So first we'll have to write the sine rule. So the sine, so I'm just writing the sine rule, sine theorem. So this is sine A over A equals sine B over B equals sine C over C. So and sine A equals B over sine B equals C over sine C. So this is the sine rule. So we just have to put to one of these equations and get 2 cos 40 for ABC triangle. So before doing that, I'll explain a little bit about the sine rule. So we can see that there's sine A and that over A, right? This simple A is the side in front of that angle. So if we get sine A is here. So in the triangle ABC, the side in front of the angle 60 on the angle A is CB, right? So that becomes simple A, and similarly by that the side in front of B becomes simple B, and side in front of simple C becomes C. So that's the sine rule. So we just have to put these values to one another. So I'll put it to the first equation. So I'll erase the second one. We don't need that. So then this A is equal to, I'll write it here, it's easier. A is equal to CB and simple B is AC, and simple C is AB, right? So I will just put these things to this equation. Then it will be some side A over CB, which is simple A, equals sine B over simple B is AC, sine C, C is AB, AB. So now we just they are asking us about AC and AB, right? So we don't need this CB, so I'll just neglect it. I'm taking these two only, sine B and sine C. I'll write it here. So sine B over AC is equal sine C over AB. So they are asking us AC over AB. So I'll take this AC to the other side and sine C to this side. So like AC to this side and sine C to this side. Okay. So then it will be AC over AB equals sine B over sine C. Now we know that sine B, this B is the B angle, right? So sine B is sine 80. So I will just write it at that. So then sine C becomes 40. We found it earlier, you know. AC over AB equals sine 80 over sine 40. Now we have to get 2 cos 40 from this sine 80 and sine 40. So what I'll do is that we know that 80 is equal to 2 times 40, right? So I'll write it. And now we have sine 2 times 40. For this sine 2 times 40, I will put the sine 2a theorem. So that will be COAB. So we know that sine 2a is equal to sine a into cos a, right? So I'll just putting this theorem to this 2 into 40. So then it will be 2 sine 40 into cos 40 over sine 40. And now we have sine 40 here and sine 40 here. We can cancel them out because similar terms. So we have 2 cos 40. We proved the first part, that AC over AB is equal to cos 40 degrees. Yes, that is it. Thank you. Next, okay, let's go to the other part. And it says next, using the sine rule for triangle ADC, show that AC over AD is equal to sine 20 plus alpha over sine alpha. Yes. Okay. So they are asking us to using the sine rule. So in the parts before that I showed the sine rule, right? So there's no point I'm writing it again. You can, but it's time based. So I'll just write similarly. By applying the sine rule, for ADC triangle. So I'll write it like this, and then I'll write the sides that they asked for only, AC and AD. So they are asking us that AC over AD. So AC over AD, so I said that the angle in front of it, so then I write AC over the angle in front of it is 180 minus 20 plus alpha, so sine 180 minus 20 plus alpha equal, the other side they are asking for us is AD. So AD, the angle in front of it is alpha. So I'll write AD over sine alpha. Right, so they are asking us about AC over AD. So I'll take the AD down. I'll take AD to this side and this whole thing, whole thing to the other side. Sine 180 minus so AC over AD is equal to sine 180 minus 20 plus alpha over sine alpha. Okay, now we know that when we subtract, like if we say the sine minus the sine 180 minus theta, this will become sine theta. It's called the Quadrant Rule. So we take it by the Quadrant Rule. So this theta here is 20 plus alpha, right? So I'll just write. So then there's no. So from this, I'm writing that this AC or AD. I'll write it here. It's easy. This AC over AD is equal to so I said that when you subtract anything by 180 minus theta, it will be sine theta, right? So then it will be sine 20 plus alpha over sine alpha. So I think that's there. So they asked us to prove yes. So then we prove that AC over AD is sine 20 plus alpha. So that's it. Okay, we'll do that part. It says deduce that sine 20 plus alpha is equal to 2 cos 40 degrees sine alpha. Yes, so if you look closely, you can see that sine 20 plus alpha equals this 2 cos 40 sine alpha. We all proved those things. So then we just have to equate this and then we can get that equation. Right? So what I'm going to do is I'm going to equate the AC over AB and AC over AD. So we know that AB and AD are equal, right? That's data. A, B is equal to AD. So we know that AB over AD is equal because they have given it, and you can see that AC and we have both AC and AC, right? So that's the same side, so that is anyway equal, and then we can say that then AC over AB and AC over AD is equal, right? Because AC over AB will become equal to AC over AD. So then we can say that those two are equal. So then we can say that 2 cos 40, I'm writing it here, 2 cos 40 degrees is equal to sine 20 degrees plus alpha over sine alpha. And then all I have to do is take this sine alpha to the other side, right? So that's, so then we prove that sine 20 degrees plus alpha is equal to 2 cos 40 sine alpha. So that's that. And then they say hence show that cot alpha is equal to 2 cos 40 plus 20 cos sine 20. Sine 20 that මේකෙන් හදන්න කොට්ටක් හදන්න. So මේක expand කරොත් මේ is equal to 20 cos 40 sine alpha. Sine alpha with sine alpha cos 20 ना. So मेरा sine alpha मेरा cot so then cos 20 आगे ना and 20 आगे. Okay, let's do the other part. Sorry, they say hence so that cot alpha is equal to 2 cos 40 minus 20 cos cot alpha is equal to 2 cos 40 minus cos 20 over sine 20. So they are asking us to get cot alpha from here. No? So I'll expand this sine 20 plus alpha here. So sine 20 into cos alpha plus cos 20 into sine alpha is equal to 2 cos 40 sine alpha. So then I will take this sine alpha to the other side, or then I can divide both sides by sine alpha. Then this sine alpha and this sine alpha will be cancelled, and here I can say that this sine 20 into cos alpha over sin alpha plus cos 20 into sin alpha over sin alpha is equal to 2 cos 40 degrees. And then you can see that sin alpha and sin alpha getting cancelled, and I can say that sin 20 into we know that cos alpha over sin alpha is cot alpha, so I can write cot alpha plus we have cos 20 here is equal to 2 cos 40. Then what I'm going to do is I'm going to take this cos 20 to the other side, and then then we have sin 20 degrees into cot alpha here. Then I'm taking that sin 20 degrees to the other side also. Then it will be cot alpha then I'm taking this sin 20 to the other side. Then we are having cot alpha is equal to 2 cos 40 minus cos 20 over sin 20. Okay. Yes, so that's they are asking to prove. Let's get on with the question. Okay, let's get on with the question. It says now using the results above in part 1, show that alpha is equal to 30. Right there, good. So you can see that now in the part 1 we got that 2 cos 60 minus theta minus cos theta over sin theta, right? So if we say that theta is equal to 20, these two equations will become equal, right? So I'll get that. So I'm saying that if theta no, it's not if, sorry, it should be let theta is equal to 20, then I'm saying that 20 cos 60 minus 20 minus cos 20 over sin 20 is equal to root 3. Then I can say that 2 cos 40, 2 cos 40 minus cos 20 over sin 20 is equal to root 3. So if I take this as equation 1 and if I take this as equation 2, I can say that 1 is equal to 2. So I write it here, 1 is equal to 2. Therefore we can say that cot alpha is equal to root 3, right? So then we know that we can say that cot inverse, so then alpha is equal to cot inverse root 3, then this is equal to 30 degrees. So that's the end of part A, I think. Yes, that is it. Now we'll get on to the part B. Okay, let's do the B part. It says solve the equation cos 4x plus sin 4x is equal to cos 4x 2 cos 2x plus sin 2x. So the important part here is that they are asking us to solve the equation, not prove the equation like in the part A. So we don't have to prove that the left hand side is equal to right hand side or the right hand side is equal to left hand side. So what I'm going to do is that I'm going to solve the left hand side and the right hand side simultaneously. So first, before that, I'm going to take the similar terms to the same side. So I'm going to take the sine 2x to the other side and cos 4x to the other side. So then it will be sine 4x minus sine 2x is equal to cos 2x minus cos 4x. Then I'm going to apply the sine C minus sine D theorem to this left hand side. So sine C minus sine D is 2 cos C plus D over 2 sine C minus D over 2. So then I'm going to apply the same theorem to this side. So it will be 2 cos 4x plus 2x over 2 and into sine 4x minus 2x over 2. So over 2. So that is the left hand side. So I'm going to write the right hand side. To the right hand side, it will be cos C minus cos D. Cos C minus cos D is minus 2 sine C plus D over 2 cos C minus D over 2. So then I'm going to write minus 2 sine C plus D over 2. So C is 2. So then minus 2 sine 2x plus 4x over 2 into cos 2x minus 4x over 2. Sine. Well, sorry, it should be sine here. So cos C minus D, cos C minus cos D is minus 2 sine C plus D over 2 sine C minus D over 2. Yes. So that's it. Then I'm going to solve the both sides. So first I'll take the left hand side. So it will be, so we have cos 4x plus 2x over 2. So 4x plus 2x is 6x and we'll divide it by 2, it will be 3x and it's 2 cos 3x into when 4x minus 2x over 2, so it will be sine x, right? So then I'm going to write sine x. We have minus 2 here, minus 2, and we have sine 2x plus 4x over 2. So that will be 6x over 2, then 3x, sine 3x into sine minus sine minus x. So then we know that we can write sine minus x as minus sine x, right? So then I can take that minus to the to this side, minus, and then multiply it by this minus and make it plus. So then both sides become positive. So I will write it again: 2 cos 3x into sine x equals to sine 3x into sine x. Then we can see that there are similar terms in both sides, right? So I'm going to take this part to the other side. So it will be 2 cos 3x into sine x minus 2, because we took it to the other side, it becomes negative, minus 2 sine 3x into sine x is equal to 0. And now I'm going to take this, take the similar terms out. So I can take 2 and sine x out, because those terms are similar, right? So minus and this and this. when I take them out, it will be 2 sine x cos 3x minus sine 3x is equal to 0. So I took the common terms out. Then can I write it here? It's easier for me. Never know how that. So I'm writing this here again, so it will be easier. 2 sine cos should be sine x, then 2 sine x cos 3x minus sine 3x is equal to 0. I'll erase this. Now, so we can say that 2 sine x is equal to 0 and or cos 3x minus sine 3x is equal to 0. Then I can say that sine x is equal to 0 because 0 divided by 2 is 0. I'm saying that sine x is equal to 0, or I'm taking this minus sine 3x to the other side. Cos 3x is equal to sine 3x. Sine 3x. Sine 3x, and then we can still simplify this. I'll write sine x is equal to 0 again, or I'm dividing this whole thing by cos 3x. I'm not going to take this side, this side. I'll divide both sides by cos 3x. Then this left hand side will become 1 and the other side will become tan 3x. Or 1 is equal to tan 3x. So sine 3x or cos 3x tan only. ඊට පස්සේ sin x, so we have sin x equals 0, right? We have tan 3x is equal to 1. So what I'm going to do is I'm going to I'm going to write it as sin x is equal to sin 0, and tan 3x I'm going to write it as tan 1. So we know there are something called general solutions, right? General solution of sine so if sine theta is equal to sine alpha, we can say that theta is equal to n pi plus minus 1 to the power n alpha, where n is an integer. Make a sine වලට විතරයි. So this n is in integer කියන එක අනිවාර්යෙන් ලියන්න ඕනේ. ඒක ගොඩක් වැදගත් දෙයක්. ඊට පස්සේ අපිට තව දිනවා tan වලට. මම tan එකක් තියන්නම්. If tan theta is equal to tan alpha, theta is equal to n pi n pi plus alpha, where n is an integer. මේ n is an integer කියන අනිවාර්යයෙන්ම ලියන්න ඕනේ. ඒක ලියුව නැත්නම් වැරදි දානවා. so මෙන්න මේ general solutions වල මම theta x කියනවා, alpha 0 කියනවා. මම මේකම ආයෙ මෙතන ලියනවා. so මේ මොකනවා මේක. ඊට පස්සේ මට කියන්න පුළුවන් දැන් මේක theta equals alpha කියලා දැම්මොත් මෙතන theta වගේ තියෙන x නේ. so I'm writing x is equal to n pi plus minus 1 to the power n alpha. alpha කියන්නේ 0, where n is an integer. මේක අනිවාර්යයෙන්ම ලියන්න ඕන alpha කියනවා. ඊට පස්සේ අපිට පේනවා මේ so this side is getting multiplied by 0, so it gets cancelled out. So then x is equal to n pi, where n is an integer. So so the other side we have tan 3x is equal to 1. So tan 1 is equal to 45 degrees, right? So 45 degrees is pi over 4. You can write anything you want. So I'm going to write pi over 4. So tan 3x is equal to tan pi over 4. So then I'm going to apply the same tan general solution of tan to this side. So it will be 3x, because we have 3x is theta in the other case. So 3x is equal to n pi plus alpha. So we are writing pi over 4, where n is an integer. So I you know this you have to write this n is an integer. It's very important. So our work in the left hand side is done. Now we have to simplify this right hand side. So I'm going to take this. We have 3x, right? So I'm going to take this 3 to the other side. So it will be x is equal to n pi plus pi over 4 over 3. So then x is equal to n pi over 3 plus pi over 12, where n is an integer. So we solved that equation. That is it. Yeah, we solved that equation. Cos 4x plus sin 4x equals cos 2x plus sin 2x. So that's it we have to prove in this. So thank you.